Welcome to Math Solve. In this video, we are going to see the gradient of two perpendicular lines. And as you can see, I have already the two line, and we just imagine that they are perpendicular to each other. So let's say this is perpendicular. So line one. Let's say this is our line one, and the red one is line 2, and as I said that they are perpendicular to each other, and we would like to see the relation of their gradient. Okay, now if I say that the first line is making an angle of alpha, for instance, and second line is making the angle of beta with positive x-axis, that's why I'm just showing in that direction. So positive x-axis with the positive x-axis making alpha, and we know that if I say the line 1, the gradient of line 1 is m1, I can easily say is m1 will be tan of alpha, and m2 will be the tan of beta, because we know that it's a tangent of the angle is creating with the positive x-axis. That's called the gradient or slope. Okay, now the issue is we are trying to make the relation between m1 and m2. So it means we have to make a relation between alpha and beta. And you can obviously see, if I just use the different color now, so you can see that angle. If you have this one is alpha, I can easily mark this one as a 180 minus of so if this is alpha and this is beta, obviously this is 180 minus of beta, that part. Why? Because this is the straight line angle, and this part, the purple one, is beta. So the red one will be the 180 minus beta, the straight line angle. Now you can see now that your alpha, 180 minus beta, and 90 degree all are within this triangle. And if I just mark it down, like probably this is our O, the intersection between two lines, and maybe this is, like, let's say that I'm marking as A, and this intersection is a B. So now we have a triangle which is a right angle triangle, OAB. Okay, so we have a right angle triangle, right? So OAB is the right angle triangle, and now I just mentioned it's a right angle triangle, OAB. And here we have one angle 90, other is alpha, another is 180 minus beta. If I say what is your tan alpha, for instance, in there it's a right angle triangle, so I can easily write down the tan alpha equal to, if you know that alpha is giving the opposite over adjacent, tan theta, soka toa, opposite over adjacent, and for alpha, OB is the opposite, and if I write down adjacent, which is OA or AO, okay, so this is opposite over adjacent for alpha, and AB will be the hypotenuse, we know that. Okay, if I ask you how about tan of alpha, it's 180 minus beta, so how about tan of 180 minus beta? So if I just write down 180 minus beta, 180 minus beta, then I am talking about this angle, and in that case our opposite will be OA, and our adjacent for this one will be OB. Right, because AB again is hypotenuse in this triangle OAB. Right, now you can see that OA OB, and this is OB OA, reciprocal, right? So it means if I reciprocal it, if you reciprocate this one, it would be cot of 180 minus beta, which is equal to OB over OA. So if I just reciprocate that part, it would be cot of alpha 180 minus beta equal to OB, and which is equal to tan alpha, right? Which is equal to tan of alpha. So I am trying to relate alpha and beta, and you can see now that that is coming now. Okay, so what is, so tan of alpha we know is m1, right? And we have cot of 180 minus beta, and you know that cot 180 minus beta, it will be cot, right? And 180 minus beta is a cot beta, but cot 180 minus beta is minus cot beta. It's just trigonometric rule. So if we go for cot of 180 minus beta, it will give you minus cot beta, which is equal to tan alpha. Tan of alpha. right? Tan alpha. Now cot beta, and we know that tan beta equal to m2. So can we write down cot beta in terms of tan beta? Yes, it is just reciprocal, right? So 1 of tan of beta equal to tan of alpha. So basically, you know, the tan alpha we know is already m1, so we can just substitute here m1, and then tan beta we know is m2, so minus 1 over m2. So you can see there is a kind of relation, m1 equal to 1 over m2 negative. So it means the m1 and m2, they would be the negative reciprocal, and otherwise you can just write m1 times m2 will be the minus 1. So m1 and m2 will be the negative reciprocal. And what does that negative reciprocal mean? I will show you in a minute. Then we can find out the gradient for this line by counting the grid, rise over run. We know that. So if I do, for example, m1, so I'm talking about the gradient for the first line. What is the gradient of the first line? So if I go for the first line, and so blue one, you can count that with the, like, maybe I can change the color in case. So we can just count the rise over run, right? So we can see that our run 2 and then our rise, if I just go from here to here, is a 4. So 4 over 2, which is giving us 2. And if I say what is our then m2, so this is our m1 and m2 for the red line. If I just go again, this point is our rise from here to here, and then go for run from here to here, 1 2 3 4. So 4 is our run, and then our rise will be 2, so rise over run. But you can see here is basically the negative direction, because you have to go without taking the pen out. So it means we are going like that and then going like that. So it means you are making negative move for the x, so like that. So it is giving you minus half. So you can see now that m1 and m2, if you multiply, it will be, so if I just show you here m1 m2, then it is giving you 2 minus half, we are multiplying, which is giving us minus 1. And that's the relation of the gradient between two perpendicular lines. So if the lines are perpendicular to each other, they are just reciprocal, negative reciprocal for the other perpendicular gradient. So for example, if we have a line with the gradient 5, the perpendicular of it will be 1 over 5, but it's a negative. If we have negative of 1 over 3, for example, and then it would be positive 3 for the perpendicular line. So that's how the sign is changing, and also the number would be reciprocating. 1 over 3 will be 3, or 3 will be 1 over 3. And if I ask you now what is the equation of this line 1 and line 2, you can now straight away say, because line 1 we know the gradient, and if I write down in the gradient intercept form, obviously we just write down the equation in a, like the first one obviously will be, if I just put in a side note, so our line 1 will be y equal to, you know, that is a 2x, so 2 is the gradient. And what is the y-intercept? So we need to count again, 1 2 3 4 4, so it means plus 4. That's the equation for the our first line. And line 2, y equal to, then you can see the gradient is changing to minus half, so 2 will be minus half, and then our y-intercept is a 1 2, so it's touching as a 2 grade in the y-axis, so it's positive 2. So these are the equations of the lines who are perpendicular to each other. Thanks for watching. Please subscribe my channel to see more up-to-date videos.